In the last video, we understood the objective of regression using the profit and investment example. We learned that the points on the scatter plot are needed to be converted into a line so that we can predict the response variable for any given value of the predictor. This line is also known as the regression line. The method used for converting the scatter plot points to a line is known as least square method. We will look at the least square method in detail in the third section of the course. For now, assume that we have managed to make the regression line using the points on the scatter plot. We need to discuss some features of this regression line. This regression line has two components, slope and intercept. We can also call them regression coefficients. Slope is also known as gradient and is denoted by the notation m or b1. Intercept is denoted by the notation b or b0. For any given regression problem, there can be only one value for intercept. On the other hand, the number of slope values would be equal to the number of predictors. For the investment and profit example, since there is only one predictor, that is investment, there would be a single value of slope. Let's understand intercept. Look at the three scatter plots on the screen. We are depicting the predictor variable on the x-axis and response variable on the y-axis. Let's say, using the points on the scatter plot, we arrive at these three regression lines. In the first scatter plot, the regression line is indicating that an increase in predictor variable is causing an increase in response variable. In the second scatter plot, the regression line is suggesting that the increase in predictor variable would cause a decrease in the response variable. And finally, in the third scatter plot, we can see that the change in predictor variable is not able to cause any change in the response variable. In all these plots, notice the location of regression line where the predictor variable is 0. The value of response variable at this location where predictor is 0 is known as intercept. We will understand intercept using an example. Suppose the annual marketing expenditure of some random company is the predictor variable and sales of the company is the response variable. This plot represents the relationship between expenditure and sales. Let's say, based on the relationship between marketing expenditure and sales, we arrive at this regression line. This regression line is telling us the value of sales for any given value of marketing expenditure. In addition, this line is also giving us an idea of sales when the marketing expenditure is 0. The expected value of sales when the marketing expenditures are 0 is the intercept value for this regression problem. Next, we are going to understand the slope of the regression line. Slope is the change in response caused by some given change in predictor variable. In terms of formula, we can say that the slope is the change in response variable divided by the change in predictor variable. To understand the slope formula, we will look at an example. Suppose this regression line describes the relationship between marketing expenditure and sales. This line is an infinite series of points that are combined together to form this line. Let's say this point on the regression line is suggesting sales of 1000 rupees corresponding to 50 rupees of marketing expenditure. Similarly, this point is indicating that the sales corresponding to 200 rupees of marketing expenditure is 2800. Let's place these values in the slope formula. In this formula, numerator depicts the change in response variable. Since sales are increasing from 1000 to 2800, we will subtract these two values to get 1800. Next, denominator depicts the change in predictor variable. Since marketing expenditure are increasing from 50 to 200, we will subtract the two values to get 150. The value of slope for this regression line is therefore 1800 divided by 150. The point to keep in mind is that if you know any two corresponding values of predictor and response in the regression line, you can calculate the value of slope for that regression line. Next, by placing the slope value in the line equation, we can calculate the value of intercept for this regression line. Line equation is y equal to mx plus b, where xy represent any corresponding value of predictor and response in the regression line. M is the value of slope and B is intercept. We already know two corresponding values of predictor and response for this regression line. Let us place one of the two corresponding values of predictor and response and the value of slope in the line equation. If we solve this, we would get 400 as the value of intercept. Now we have the value of slope and intercept for this regression line. The relevance of these two values is that by using slope and intercept, we can make the regression line. Let's see how we can make the regression line using these two values. In this plot, x-axis represents the predictor marketing expenditure and y-axis represents the response variable, that is sales. First, we will locate the value of intercept, that is 400, on the y-axis. This is the value of sales when the marketing expenditure is 0. Next, the slope value is 1800 by 150. In other words, a 150 rupees increase in marketing expenditure is causing a 1800 rupees increase in sales. From the intercept, we will first move 150 towards the x-axis, and from there we will move 1800 points towards the y-axis. We can connect the intercept and this point to make the regression line. This line depicts the relationship between marketing expenditure and sales. Let's revise what we have covered in this video. We started off this video by looking at the formula of slope. Using this formula, we calculated the value of slope for an example. We then looked at the line equation y equal to mx plus b. By placing the value of slope in line equation, we arrived at the value for intercept. Finally, we used the slope and intercept value to make the regression line. Remember, we are yet to look at the least square method that is used for making regression line using the points on the scatter plot. We will look at the least square method in the third section of the course. We are concluding the first section of this course with this video. In the next section, we would cover some fundamentals of statistics that are related to regression.